Namaste. Hope you are doing well. Today we will solve the second question of ISI MSTAT 2024 PSB. And it seems to be a number theory question because you are given a set S and told to prove that its elements are infinite, wherein the set S has its elements have a structure of rational couplets with a constraint. When rational numbers show up and you have a hint, something like this, completion of whole squares and whatnot, it directs towards number theory. So let's get started. Before even connecting the dots, we have to build some intuition. And in this case, it's going to be how to use this hint, how to make this hint more usable. Because it's seldom the case that the question makers would just give you the hint and the very next application of the hint is the answer. No, they'll deliberately mess up the hint a little bit or make it a little slightly complicated. In this case, how can we make this hint more in terms of something that we have over here? And that can be done, if you have not figured it out already, by taking this thing in the RHS down in the denominator for LHS. And then it becomes a structure that resembles a lot with the structure that is there as the constraint of the elements in S. So this was necessary to do. Otherwise, just looking at this alone may not have been sufficient, at least not for me. Now that we have the hint as more usable, how do we actually use the hint? And in a way, it's simple. If you think of this as x square and think of this as y square, then this adds to 1. Now you just have to rationalize in a way that x and y are rational. So let's start with that. Take x as this and y as this, basically the square roots of these things. And then look at things. This here is a rational number for sure, no matter what's the value of it. Because a rational number is the ratio of two integers. And in this case is an integer. This thing seems to give the problem. Denominator, definitely integer. Numerator, slightly tricky. Is it or is it not an integer? But the catch is, we have the freedom to play around. And that should not stop us to take this symbol of square root, which is usually or rather psychologically associated with irrational forms. We should not let that stop us. And because we have the freedom to play around, we can just choose this thing to be an odd integer k. And it's possible because the perfect squares, if we take 2n plus 1 as perfect square k square, then its square root is going to be an odd integer when that perfect square is an odd perfect square. Let me just put some numbers in the picture. So if you have something like 2n plus 1 equals to 3 square, which is 9, then you can have root 2n plus 1 as 3 plus or minus 3, right? And more than that, you can also find the value of n, which is 9 minus 1 by 2. So 4. So it makes sense for one case. Now all we have to do is generalize using notations. And that's how we go about it. We have the structure. Now what? Find the value of n in terms of k or k square and substitute. Let's start with y. This becomes anyway the plus minus k because that's how we chose it. And when we substitute n, we substitute k square in n, the form of k, then this thing is what we get. And if we just take the plus 1 inside, then this is what we get. And this is a rational number in general because k is an odd integer. And so k square plus 1 is even. An even integer. An even integer divided by 2 has to be an integer. It will not involve decimals. Similarly, if we look at x, then substituting n and n plus 1, we would get this and this. And because we chose k to be an odd integer, k square minus 1 and k square plus 1 both are even. And if you divide both of them by 2, they are again some integer. And that's it. Now, how to write things? Exactly write what we did. Fix any odd integer k and choose the following values for x and y. This and this. Argue that this is rational because the numerator has to be an integer because k was chosen as odd. Same for the denominator. Same for the numerator over here. Same for the denominator over here. And by the definition of a rational number, which is essentially the ratio of integers, both x and y are integers. And more than that, when we sort of square and add x and y, x square plus y square, we get 1 because this thing in the numerator and this thing in the other numerator, when we square it and add, we get what is there in the denominator, that thing square. And that's it. So that's for any fixed integer k. Because there are infinite odd integers k, so we can have infinite of such constructions. So for each k, we can have this kind of construction that would give us a member for the set S. And yeah, there is a lot in this direction as well. And that's how we say that the set S has infinitely many elements. And another perhaps cautionary note is, what if the same k would give something like this? What if from k equal to 3, you're getting something, some x and y, but from k equal to 7, what is the claim that x and y may not be the same as this? What if all the different k's are giving me the same answer? That can be countered by noting that the structure of x and y is chosen involving only the degree 2 as the highest degree of the polynomial structure of k. And because a quadratic can have only 2 roots, so there is possibility of having a similarity in the structure only for 2 values of k, not more than that. So essentially what can happen is, even if you use all these k and make elements for set S, and because the set has to have distinct elements, even if you remove the common elements or repeating or recurring elements, you would still have infinite elements. And that's it. Some base to build your base is, when in doubt, take down the puffed up entity to see things clearly. In this case, our puffed up entity was n plus 1 whole square. This was perhaps something in the hint that was stopping us from making the hint more usable. But the moment we sort of took it down as the denominator, we could see the hint much more useful. And if you like this, then do share how putting down your ego, your puffed up ego, helps solve a problem in your life or someone else's life. It usually does. Putting down ego usually does it. Take care. Hare Krishna.